Here we are given two polynomials, p and d, and we are to use synthetic or long division to divide p of x by d of x and write the result as the quotient plus the remainder divided by the divisor. This is a similar process to taking an improper fraction and writing it as a mixed number. So we're going to start with x minus 2 and divide that into x cubed plus 0x squared plus 4x plus 3. Notice in the original the x squared term was missing, and so we use the 0x squared to keep the place or as a placeholder for the x squared terms. Now, there's going to be a three-step process that we do over and over again until the remainder has degree less than the divisor. Here the divisor is degree 1, so the remainder will have to be degree 0. That means it'll have to be a constant. What we do is we take the leading term of the polynomial that remains, divide it by the leading term of the divisor. This gives us x squared. And x squared is going to be the first term written in the quotient. I like to write it on top of the other x squared terms. I line up the terms in the quotient with those in the body of the division. The next step is to multiply the x squared by x minus 2 by the divisor. That's going to give us x cubed minus 2x squared. Now we're going to subtract. Notice that there's a 0x and a 0 under the 4x plus 3. So as we subtract, 0 subtract negative 2 is positive 2x squared. 4x take away 0x is 4x. 3 take away 0 is 3. So those were the three steps. We're going to do the very same three steps, but this time apply them to 2x squared plus 4x plus 3. So I take the leading term of this polynomial. I divide it by x. That's the leading term in the divisor. This time I get 2x. So the next term in the quotient is 2x. Now I take 2x times the divisor, x minus 2. I get 2x squared minus 4x plus 0. Now we subtract that from the polynomial directly above it. 4x subtract negative 4x is going to be 8x. The 2x squareds neutralize each other. Now we have to go one more time. This time 8x divided by x gives us 8. So the last term in the quotient, the constant term, is 8. We do 8 times x minus 2, which will give us 8x minus 12. The 8x's neutralize each other, and we get 3 subtract negative 12, which is 15. So 15 is our remainder. In this case, it's referred to as r of x. And x squared plus 2x plus 8 is our quotient or q of x. So in this case, p of x divided by d of x equals the quotient, which is x squared plus 2x plus 8, plus the remainder, which is 15, over the divisor, which is x minus 2. Now, we were told that we could use either long division or synthetic division here. And so remember, when you're doing synthetic division, you are looking at the constant term that is being subtracted from the x. So when you're using synthetic division, and you're working with a divisor of x minus r, it is the r that you use as the divisor in the synthetic division. So in our case, the r is 2 because we're dividing by x minus 2. I prefer to put my little bracket here around the r instead of around the polynomial that is being divided. It's your choice. Now, as we list the polynomial, it is only the coefficients that we list, and we need to make sure we don't leave any out. So p of x was 1x cubed plus 0x squared plus 4x plus 3. Now, we drop the 1 down. We multiply 2 times 1. That goes here, so that's 2. We add the 0 and the 2 to get 2. We take 2 times 2, put that result here, add to get 8, take 2 times 8, which is 16, add to get 19. And this is a good reason for doing the division both ways, because I have just come up with a discrepancy between what I have as a remainder in the synthetic division and what I had as a remainder in the long division. I'm sure you caught it before I did. Notice that when I went 8 times negative 2, I got negative 12. And I should have gotten negative 16. So we should have had 3 subtract negative 16, which was 19. So it should have been our q of x plus 19 over x minus 2. Now, let's go back and interpret the rest of our answer here. Since we were dividing a third-degree polynomial by a first-degree polynomial, we can subtract those degrees to see that our quotient should be a second-degree or quadratic equation. So the 8 is the x to the 0 term, or the constant. The 2 is the coefficient of x to the first, and the 1 is the coefficient of x squared. So our q of x here, using synthetic division, comes out to be 1x squared plus 2x plus 8. And happily, that's the same thing we got with the long division. So the answer is that the quotient is equal to x squared plus 2x plus 8 plus 19 over x minus 2.